Hey everyone out there on YouTube. I want to wish you a Merry Christmas or a Happy Hanukkah or a Happy Kwanzaa or a Happy Solstice, or maybe you don't celebrate any holiday this time. I'd like to wish you happy holidays or none, whichever is appropriate for you. And today I want to talk about push-top ratchet mechanisms for mechanical pencils. These are the most common mechanisms that exist for mechanical pencils that are sold today. And there are other mechanisms, of course. There's shaker mechanisms and clutch mechanisms and all sorts of twist mechanisms, all sorts of mechanisms that you can use to advance the lead on a mechanical pencil. But today I want to talk about the push-top ratchet mechanism, being the most common, of course, but I think that for a lot of people, in terms of keeping your mechanical pencils in great working order, understanding how the mechanisms work can work wonders in terms of helping you to make sure that your mechanical pencils are in top working order. And so as you can see in front of you, this is a Pentel Sharp P205 in carbon black, which has sort of this silver and black pattern. A viewer of the channel had commented on that recently, and so I thought I'd use it as the example. But I'm also using a Pentel Sharp because Pentel has a reputation of having a great mechanism. And of course, the Pentel Sharp has this push-top ratchet mechanism. And so what I want to do here is take it apart and talk a little bit about how it works and maybe try to do some sketches for you because there isn't really a lot of stuff out there on the web on how mechanical pencils work. I was kind of shocked when I was doing research for this video of what isn't available in terms of helping people to understand what's happening here. And so let's go ahead and dive right into taking this mechanical pencil apart so that we can understand what's going on. So step one of a Sharp is you unscrew the end. There we go, and you can see that there's the lead is extending out of here. Now, one thing that we can talk about with regards to push-top mechanisms is that most push-top mechanical pencils have a single gripping part, and then you'll notice that there's this huge length right here of lead that is unsupported within the pencil. Now, Pentel Sharp is an awesome pencil, okay? I highly recommend it to everybody. But one of the downsides of a single clutch or chuck mechanism, which is true of most mechanical pencils, is that there's this large piece of lead here that is exposed, and this is this is when you get lead breakage right here, because there's a big part of the stick of lead that is not supported, and since it is not supported, if you jostle your mechanical pencil around, if you drop it, there's essentially a weak point to the mechanism where it can break. Now, there are mechanical pencils that have been developed with double clutch mechanisms. Good example would be the Platinum Zero Shin, or also known as the Stettler Integrity is the old version of this model. And then I don't have one out right now, but Zebra Delgard has a double clutch mechanism that holds the lead in two places. With regards to the Platinum Zero Shin, the lead is being held securely by the tip, and it's also being held securely within the pencil so that you can use the lead all the way down to basically the last millimeter. For the Zebra Delgard has a double chuck or double clutch mechanism that allows you to hold onto the lead in two different places so that it is more supported and less likely to suffer lead breakage. I should probably talk a little bit about terminology here. You can use the term either chuck or clutch. It doesn't really matter which one you use. Because different manufacturers specify different names for the different components of their pencil. And before we go any further, we should probably talk a little bit about what it is that I'm talking about here. And so let me get another pencil here. I'm going to use the Pentel Smash, which is no longer in production, unfortunately. And I want to do a little sketching for you here so that you sort of understand what's going on. Inside a mechanical pencil, there's a piece that holds the lead. And if I sketch this really large, basically what I'm sketching here is this circular internal component that you can see holding the lead in the center right here. This is called the clutch or the chuck, okay? And so if I sketch, this is like if you were holding it just as I was holding it, you're looking into the pencil, down the barrel of the pencil, up towards where the eraser is. And so if this is a brass or plastic ring, okay, on the outside, and then on the inside, at 120-degree angles, we have 3 metal pieces that are holding this piece of lead here in the center. Okay, and so there's a brass ring on the outside, and then each of these are actually 3 independent pieces that are sort of nestled within this brass ring. So if I sketch it with a little bit more detail here, there is a piece here, and then there's a piece over here. These are all independent pieces of each other. Each of these are a portion of this inner part called the clutch or the chuck. And I'm purposely exaggerating the gap between each of these pieces. These are a lot more snugly fitting than what I'm drawing here. I'm just trying to draw it here so that you can sort of understand what's happening with it. And so if I shade these in, hopefully that'll help these pieces stand out, because what we have going on here is 3 plastic or metal pieces in any push-top ratchet mechanical pencil that are each 1/3 of a gripping mechanism that is gripping the lead in the center. Shade, shade, shade. So each of these thirds is touching the lead in the center, and I'm not an artist, so bear with me. Okay, but if this represents our lead in the center, each one of these 3 pieces is holding on to that lead, gripping it. Okay, so these 3 pieces together form the chuck or clutch, depending upon what company you're talking to. Either term is acceptable. And then there's this brass or plastic. It could be made out, any of these pieces can be made out of anything, ring on the outside that is containing these 3 pieces. Okay, so the lead's here in the center, and then these 3 pieces together form the clutch or the chuck. And the whole purpose of a mechanical pencil is to hold on to that little piece of lead and give you control over how much of that lead is being spit out while you're working with a mechanical pencil. Okay? Now, if we take a look back at the P205, you'll notice that when I press the bottom, that chuck comes out. Okay, so there's the chuck. It's divided into 3 pieces. Okay? And let me see if I can bring it up here so you can see it. And you'll notice that when it's extended, those 3 pieces open up. And when you retract it, those 3 pieces close. Opens up, close. And that's the idea behind the mechanism. You want to be able to extend the lead at some point. And when you push that top button, you are extending that clutch system out of the pencil, allowing the lead to advance. Now, I just moved this pencil so that the lead, and opened it up so that the lead dropped back down into the barrel. It's important to note here that to an extent, this mechanism does rely upon gravity to work. In other words, if you do not have a piece of lead loaded up into the barrel, no matter how much you press the push top of a pencil, you will never get lead extending out of it, because the mechanism is dependent upon gravity pulling a piece of lead towards the center of the earth, and that allows it to dock up with the mechanism. And then once lead is in a position where it can move down into that clutch, the clutch will grab it. And once the clutch has grabbed that piece of lead, it can be extended down into the pencil. So this mechanism, to get it started, you have to rely upon gravity. You will never get a piece of lead to extend out of a mechanical pencil if it is not already loaded into the clutch and if your pencil is upside down. Now, once it's loaded into the clutch, you can have it upside down and it will extend a little bit. I mean, you are essentially working against gravity when you do this. So it will extend a little bit, but not as efficiently as if you are holding it with the tip facing downward. Okay? Now, there's another component of this that is necessary because you don't want the following to happen. So I'm going to unscrew this. Watch what happens if I press the top mechanism without any sort of tip down below. The lead just falls right out. Because this mechanism, when you release it and open up those 3 little claws that are holding onto the lead, if there's nothing to stop the lead from moving straight through the mechanism, it'll just go straight through the mechanism. Okay. Now, this is probably a good time to talk a little bit about quality of mechanisms as well, because you'll note that in a Pentel Sharp Series pencil and in many mechanical pencils, all of these fittings are composed of brass. Cheap, really cheap mechanical pencils, the clutch system is made out of plastic. And let's just take a look at one of those cheaper mechanical pencils, if I can find one here. Okay, one that I can actually take apart to actually show you. And so some mechanical pencils, they're designed to be just individual use pencils. Okay, so here's one that I haven't. Nope, that's not going to do it. Going to try. Here we go. Okay, so I know many of you. Nope, that's not it. Clearly, I should have been more prepared for this. Here we go. Here we go. So, if I take a cheaper mechanical pencil, an economy mechanical pencil, I didn't want to show this one because I'm going to be featuring it in a video coming up pretty soon, but I couldn't find one here, so we're going to use this. If we take a look at the... Oh, nope. You got to get one where when you take it apart, you can actually see the clutch. That's the problem with it. And so how about this one? Nope. So I guess I don't have a pencil at the ready here that actually has a plastic clutch. And I'm going to be honest with you, I don't favor mechanical pencils with a plastic clutch for a couple of good reasons. One, plastic is cheap and easy to mold. The problem with plastic is that as you continue to use it, it wears down. And as it wears down, it loses its ability to hold on to the lead. And this is why economy pencils eventually wear out and you can't use them anymore, because the mechanism inside them, as it's going through this action, continually wears out. One of the other problems with plastic is that it does not grip the lead as well as metal would. And I mean, that should make logical sense to us, because really nice engineered metal is going to grip onto that lead a lot better than plastic, which has a bit of a smoother surface. There's not as much friction between the plastic and the metal, and as a result of that, you get lead slide errors happening a lot more in plastic mechanical pencils than they would in metal mechanisms. So metal mechanisms are essentially more precise. And of course, Pentel has a really famous... Pentel is famous for having a great brass clutch system in their pencils. A lot of people wish that they could get a Pentel mechanism in a pencil from another brand because they're just so good. And so that's something to consider when you're considering buying a mechanical pencil that you've never thought of before. If it's a push-top ratchet mechanism, what is the clutch made out of? If it's made out of brass, it's going to be a lot easier to work with. Okay? Let's continue our little tour of the mechanism here of the Pentel Carbon Black. This whole piece of the Pentel Sharp is made out of brass metal, long-lasting. Very fine, very nicely machined threads are going to screw the tip of the mechanical pencil on for a Pentel Sharp. These are some of the features that you would expect of a quality mechanisms. You'll notice that there's also a spring here, and that when you press down, the spring compresses, and when you let go, the spring extends. And what we have going on here, of course, is that when you press the top of a push-top mechanism, you only want a small amount of lead to extend out when that clutch extends out, and then when it retracts back, it is gripping the lead again. So when you push down, you are compressing the spring while simultaneously expanding the clutch so it lets go of the lead. And then when you let go, the spring pushes the clutch back up into the holding receptacle here, gripping onto the lead again so that you don't get too much lead extended out. So spring compresses, let go of the lead, spring expands, grip the lead again. And that's how a push-top mechanism mechanical pencil works. Now, this spring can be of varying quality as well. Okay, I've seen mechanical pencils where the spring is basically a gigantic joke, and we shouldn't even bother with it at all. And so that's another thing to consider is the quality of these pieces of the mechanism makes a huge difference in terms of what you are getting when you purchase a pencil. You know, some of you might have been wondering why do people like these Pentel Sharps? It's just a hunk of plastic and it doesn't have a knurled grip or anything like that. It's basically just a plastic grip. Well, people like Pentel Sharps because in terms of their cost, this is the best mechanism you can get for the price. And so for people who prioritize mechanism over anything else, it's really hard to beat a Pentel Sharp in terms of its cost. Now, Pentel Sharps vary in cost, of course. The least expensive ones in bulk you can get for $4, the classic versions of the Pentel Sharp. And then, you know, more designer custom Pentel Sharps like the Metallic series or the recent gold primary color series that came out. Those are more expensive because Pentel is producing them in limited quantities. But for most Pentel Sharps, it's a really great price for a really great mechanism that lasts for a really long time. Now, the other thing that I want to talk about with regards to the clutch itself and having that brass clutch is the cleaning of the pencil. The problem with plastic, in addition to it wearing out a lot quicker, is that it's harder to clean plastic because that graphite can, well, from a scientific perspective, get electrostatically charged with that motion and be more likely to stick to the components of the clutch, this three-pronged system. And the more dust you get in these gaps between the pieces of the clutch, the more likely your mechanical pencil is to jam. And so another big problem with these plastic clutches is just that you're more likely to have lead advancement errors over use over time. Now, with a metal system, you're less likely to get that electrostatic attraction. And, you know, I could go into details of the triboelectric effect and how different materials have a different rating on the scale of the triboelectric series, and plastic has a different triboelectric series number than metal does. And the long and short of it is that you're more likely to get electrostatic attraction with graphite and plastic than you are with metal. So a metal clutch will resist that buildup of lead a little easier, and it's also easier to clean. When you stick a lead jam clear up into a metal clutch, you're more likely to get some of that junk out when you move it around. And so if you're having problems with jams in your mechanical pencil, jams in mechanical pencils are a natural feature of how this mechanism works. But the truth is that you're much more likely to get jams and irrecoverable jams for a plastic clutch than a metal clutch. And so one way that you can reduce the likelihood of jams is upgrade the clutch and purchase more higher quality mechanical pencils. And so we're not just purchasing higher quality, higher expense mechanical pencils because we're economically dumb and we are willing to pay more just because it's an art piece. We're putting more into mechanical pencils because you're more likely to get a clutch that will last over time. And so that's a consideration in the purchase of mechanical pencil. And so I wanted to do a video today helping you to understand this push-top ratchet mechanism a little bit better, so perhaps it helps you to clean out your pencils a little bit more and be less likely to suffer lead jams. And this hopefully will make you a more experienced and more trained consumer of mechanical pencils as well. Because ironically, there's not a lot out there on the web about the nature of this mechanism and reasons as to why you might want to understand it better so that you have better use of your mechanical pencils. And so there we go. This is part of a series that I'm doing here on the channel of trying to, directly educate people about mechanical pencils. I've done a video on mechanical pencil lead tests. I've done a video on the clutch mechanism now. and I've done a video on the science of mechanical pencil lead. And so I'm going to try to come out with more videos like this over time. What are some ways that we can learn about mechanical pencils other than just reviewing them and understanding which ones exist? So thanks for watching. Happy holidays, and I hope you have a great day. Bye-bye.